So if you look at question 24 on the multiple choice practice exam, you'll see it down there. And there's lots of different answers, and you're trying to decide which of the following statements are true. And we'll go through those answers, and I don't have them listed here, but I can pull them up on the book. So hang on 1 minute. So I have the book problem up on the screen as well. So if you can't see it in your book in front of you, you can at least look at it up here. And if we go through the answer choices, we can probably eliminate a couple of them, but the last three, we need this graphic I'm going to show you in a minute. So the very first one, part A, a p-value of 0.011 is weaker evidence against the null hypothesis than a p-value of 0.033. Why is that false? A smaller p-value means better. Earphones out, please. Okay? We want a smaller p-value. That means that we have stronger evidence, right? So that's the word weaker is the problem there. So we know it's not A. If we look at B, if we reject the null hypothesis at an alpha of 0.05, we'd also reject it at a 0.01. That's also false. Tell me why that one's false. It actually doesn't depend. Well, sort of. You're right. Give me a p-value that I could reject at 0.05, but I would not reject at 0.01. 0.04, 0.03, 0.02, anything between the two. Would you agree? So that is also false. It's answers C, D, and E that we started getting into type 1, type 2 errors and significance level and power and those kinds of things. So I'm going to kind of go back and forth between these, and I wanted to kind of just review for a second about type 1, type 2 errors, about the power of the test, and about significance. So last class in my fog, I attempted to recreate this graphic. Go ahead and see if it'll let me switch back and forth, and it does. Good. So if you remember, we have a decision that we make based on the p-value. We have the actual truth, whatever actually happens. And then we have our decisions, right? So we either decide to reject or decide to, I hate the word retain, fail to reject. Okay? And then we have whether or not the null is actually true or false in what happens. So we make a correct decision in the bluish purple and an error in the red situations. Okay? Type 2 error is what I think the problem was asking about. It's when I fail to reject a false null. The null is false, but I don't reject it. Okay? I fail to reject it. I say it's true when it actually was false. Okay? That's a type 2 error. So the next page, not this one. Well, I'll talk about this one too. In a type 1 error, if you remember, the probability of a type 1 error is the same as our significance level. Does that sound familiar to you? If you don't remember it, write it down because it's kind of important, okay? The probability of a type 1 error is alpha. The probability of a type 2 error, we can't find out exactly, but we can make some assumptions. If I increase or decrease certain things, it will affect. But the probability of a type 2 error, we'll call it beta, okay? Well, we can't find it necessarily exactly, but we can approximate it. What is this right here? It's called something. Do you remember? It's called the power of the test. When I correctly reject a false null. For example, if my null hypothesis said the probability that you're going to pass your AP exam is 95%, okay? I hate to say that that's probably false, but it is. Would you agree? Okay, that 95% of us are going to pass the AP exam. So I'm going to, and let's say that my alternative is that, it's not that. Okay. Let's say my p-value was 0.00006. What would I do with that p-value? I would reject the null. And we can pretty equivocally say that the null was false, right? So that's going to be what's called the power of the test. That's the power, okay? That's a strong thing. It's a correct decision. Now, this is the graphic that I wanted to really spend some time on. So let me turn the lights out so we can really see it. Okay, and I wrote some things on here. Remember, the top graph deals with your alpha, which is in red. And then below it is your beta. What's beta again? Beta is the probability of a type 2 error. So what's in red are both of the errors, right? Type 1 error, type 2 error. And then the power is a direct complement to the probability of a type 2 error. So pretend this slider here, okay? If I'm going to slide it up or slide it left or slide it right, certain things are happening. The power is 1 minus beta, they're complements, I get it. Reducing alpha, so if I reduce alpha, my slider is going to the right. Would you agree? If my slider is going to the right, what happens to my beta? It increases, and what happens to my power? It decreases. So those are the kinds of things we have to think about when we're answering those types of questions that you see in question 24. If I increase alpha, I'm also increasing power, but I'm decreasing the probability of a type 2 error. So this graphic here, in my mind, shows the relationship between all of those things. Does that help? So let's go through and make sure that these questions make sense. Reducing alpha will lower the chance of committing a type 1 error. Well, alpha is the probability of a type 1 error, right? So if I reduce that, that probability will go down. But we'll increase beta. Would you agree? And reduce the power of the test. So the power gets smaller, beta gets bigger. True. The large, this is the one that got me on Wednesday. The larger the real difference between the hypothesized value, and this should be P naught, sorry, okay, and the true population value, which is just P, the parameter, the smaller the chance of making a type 2 error, okay? So the further away that, let me write it here, the further away that this is from this, okay, the further, these two graphics are not necessarily aligned. If they were one directly under each other, that means that P naught and P would be the same number, right? The further they are away from each other, this line, this yellow vertical line, creates smaller rejection regions. Do you agree? These errors become smaller. So the further away these two things highlighted in blue are away from each other, the smaller the chance of an error, right? Cameron. Huh? Up here? This is your statistic. It's your hypothesized value, okay? And this is the actual value, okay? This is the truth. This is what you're guessing it to be, okay? All right. So based on that, let's look at the questions from the textbook one more time. Look at C. We can increase the power of the test by decreasing the significance level. So let's look at this graphic again. Let me put it up here so we can see the graphic. If I increase the power, that means my yellow line is moving in which direction? Left. If it goes to the left, am I also decreasing alpha? No, alpha would increase. Alpha is up here. So if I move the yellow line to the left, isn't alpha going up? So isn't that why C is false? Okay? Let's look at D. We can decrease the risk of a type 1 error. Where is type 1 error on here again? Alpha. So if I'm decreasing it, my yellow line is moving to the right. If I'm decreasing it, I'm increasing the significance level. No, because significance level and type 1 error probabilities are the same, right? So if I'm increasing one, I can't decrease. They're the same thing. Okay? So that's why D is not correct. E is the correct answer because that's what the last little bullet point was saying. The further away that these blue highlighted marks on the normal curves are, the further away they are, the lower the risk of a type 2 error. Yes. And the lower the risk of a type 1 error, too. It's the lower the risk of any of the errors. Is that clear? I hope. I hope so. Sorry about the fog from Wednesday. But I'm going to stop recording this part.